This is a video lesson on exponential growth and decay. So we're going to be looking at the growth factor in an exponential function. So when we're talking about growth or decay, we know that when we have growth, b has to be greater than 1, and when we have decay, b has to be less than 1. If you're given growth in a percent or in a rate, for growth, it's going to be 1 plus the rate. For decay, it's going to be 1 minus. So if I'm given a rate of 5% growth, b is going to equal 1.05. If I'm given 5% decay, b is going to be 0.95 because it would have been 1 minus 5%. So when we're looking at the exponential equation, we know that a is the initial value and b is the growth factor. And again, b is greater than 1 would be growth. B less than 1 would be decay. So looking at exponential growth from a table, we know that x is going up 1 each time, and we are multiplying by 4 each time. So b is going to equal 4. So in my initial value, I'm going to find where x equals 0. So then the equation for this function would be y equals 2 times 4 to the x power. Now exponential growth from a graph is going to go up, and we know the initial value is where it crosses the y-axis, so a here is going to equal 5. And if I'm looking at my points, to get from one to the next, this to this, I have to multiply by 2. So b is going to equal 2. So y equals 5 times 2 to the x power. Now in a real world example, I've got $4,500, so that's my initial value, in an account that pays 5% interest, and it pays, so this is going to grow. So this is going to be times 1.05 to the x power. And the reason for that is that 5% as a decimal is 0.05, and I know that because it's growing, it has to be greater than 1. So it's going to be 1 plus 0.05. So my growth factor is 1.05. Now we're going to look at exponential decay from a table, and for decay we know that b has to be less than 1. So I'm going up 1 on my x, and I am multiplying by 1/3 or dividing by 3. Now looking for my y-intercept, it's where x equals 0. So the equation here is going to be y equals 9 times 1/3 to the x power. And if I were looking at this equation, I can tell that it's decay because that b value is less than 1. Exponential decay from a graph, you're going to know that it's decay because it's going to go down from left to right. We're going to look for where x equals 0. So our a value is going to be 4. And to go from left to right and get from one point to the next, on the y-axis, to get from 8 to 4, we have to multiply by 1/2. So our b value is 1/2. So y equals 4 times 1/2 to the x power. Again, we can tell that's decay because 1/2 is less than 1. In a real world problem, we have a car that was purchased for $18,000, so that's going to be my initial value. And the car depreciates by 20%, so that's going to be 1 minus 0.20. So my B equals 0.8. I do 1 minus because it depreciates or it's decaying or going down. So that's Y equals 18,000 times 0.8 to the x power. So just remember that if you're given a rate of growth, if it's going up, it's 1 plus the rate. If it's going down, it's 1 minus the rate.